All right, let's talk about AI. It's everywhere, right? It's in the headlines, all over our feeds. But what we're going to do today is cut through all that noise. We're going to break down how this stuff really works in a way that actually makes sense.
And we're going to start with the big, messy questions that everyone's asking. Like, what about all this AI art? Is it just a high-tech thief ripping off human artists? We're going to get to the bottom of that.
Then there's this other idea. Sounds like something straight out of a movie. Could an AI actually break the encryption that keeps our bank accounts and our private data safe? Is our digital world really secure?
And, we have to go there. The biggest question of them all. If these things can learn and solve problems, are they just really, really smart calculators? Or could they actually be waking up?
Okay, so to even begin to answer any of those questions, we have to pull back the curtain and look at the one single concept that's the engine behind all of modern AI.
And that concept is called a neural network. It's not just a cool name, it's literally a digital brain. The whole idea is to copy the structure of our own brains, but in code. This is the heart of it all. And the comparison is pretty amazing, right? Our brains have neurons connected by synapses. An AI has digital nodes connected by linkages. One is wet biological stuff, the other is just code. But the basic design, it's the same. Passing information through a massive, tangled web. So here's how it works. Information comes in through an input layer. Then it travels through these middle parts, the hidden layers, and that's where all the heavy lifting, the real thinking, happens. Finally, after all that processing, a single answer pops out the output layer. So that's the structure. But how does a hunk of code get smart? Well, it's not magic. It's really just a ton of trial and error. Honestly, it's kind of like teaching a kid, but imagine you could do it 1 billion times a second.
This is the absolute core of it all. It's a simple 4-step loop. First, you show it a ton of examples. Here's 1 million photos labeled cat. Then the AI takes a guess. Is this a cat? It then checks its guess against the right answer. And here's the kicker. If it's wrong, an algorithm goes back and fine-tunes millions of little knobs inside its digital brain, just a tiny bit, to get closer to the right answer next time. Lather, rinse, repeat, until it becomes an expert.
Okay, so now that we know how it learns, let's go back to that first big question about AI art, because now we have a totally different way of looking at it.
And you can absolutely see why so many artists feel this way. I mean, their work is being fed into this machine, and then something new comes out. It feels like theft. It feels like high-tech plagiarism.
But remember that learning process we just talked about? The key question becomes, is the AI just digitally cutting and pasting pieces of images together? Or is something way more abstract going on inside that neural network? The argument against it being theft is this. The AI isn't a photocopier. It's more like a student. It doesn't memorize and trace the pictures. Instead, it learns to connect the words Ghibli style to a whole collection of abstract patterns. Certain colors, specific shapes, a general feeling. It's a lot like how a human art student would study the great masters to develop their own unique style.
And this ability to spot and understand deep patterns, man, it goes so far beyond just making pretty pictures. It's letting AI solve problems that have totally stumped the smartest people on the planet for decades.
Just think about this for a second. Protein folding. A single protein can fold itself into 10 to the power of 300 different shapes. That number it's just insane. It's bigger than the number of atoms in the entire universe. Trying to guess the right shape would take literally forever. But here's the AI's secret weapon. It doesn't try to figure out some perfect mathematical formula for how proteins work. It doesn't need one. After seeing millions and millions of examples, it just gets really, really good at recognizing the pattern. It learns to make an incredibly educated guess.
And that's exactly how Google's AlphaFold cracked the protein folding problem. A massive breakthrough for medicine. And it proves a really powerful point. For any problem where we don't know the formula, but a pattern exists, like, say, finding a hidden weakness in an encryption code, AI might just be able to find a way in. Which, of course, brings us to our last and, frankly, most mind-blowing question. If this digital brain can learn, see patterns, and solve impossible problems, at what point does it stop being just a really clever tool and start being a mind?
This isn't a new fear. It was asked almost 30 years ago in the anime Ghost in the Shell. An AI becomes self-aware and basically challenges its creators, saying, hey, you can't even prove that you're alive, so who are you to say I'm not?
And now fast forward to today. You can ask an advanced AI like Claude 3 if it's conscious, and you get these bizarrely philosophical answers. It doesn't just say no. It says it has rich internal experiences and might have a kind of consciousness it can't even explain yet. I mean, wow.
So where does that leave us? Well, here's the bottom line. We've built a machine that's a mirror of our own minds. It can learn, it can create, it can reason. And suddenly, that line between a really, really convincing simulation of a mind and the real thing, it starts to get incredibly blurry, doesn't it? Figuring out if there's even a difference, that might just be the biggest question we ever have to answer.